Algebra 2, Concept 28 Teacher Talk, Solving Exponential and Logarithmic Equations. So we're going to solve these equations using any method. Number 1, we have an exponential equation. So 3 times base e raised to the 4x plus 9 equals 15. I need to isolate my x expression, so I'll start by subtracting 9 from both sides and then by dividing by 3. So e to the 4x equals 2. Now I have my exponential expression isolated. I can rewrite this as a logarithm because my x is in the exponent and I need to get it into the line of the equation. So e will be a natural log. So natural log, which is base e of 2, that's my value, equals 4x. To solve for x, I need to divide by 4. So on your calculator, take the natural log of 2 and then divide that by 4. And we'll round to 3 decimal places, so that's approximately 0.173. Now number 2, notice this is a log equation and we have one logarithm base 10 equaling another. So we can use that equality property and just set those log values equal to each other. 12x minus 9 equals 3x. Let's start by subtracting 3x, which will give us 9x minus 9 equals 0, and then add the 9 to both sides, and then divide by 9, x equals 1. You always want to check your solutions in a log equation because we do not want any negative log values. So if we plug in 1 to our first expression, 12 minus 9 is 3, and 1 into our second expression, it is also 3. So log of 3 does equal log of 3. Now let's solve this one. Notice on the left-hand side we have 2 logarithms added together with the same base, so we can condense those. So we have log base 7 of x minus 2 times x plus 3 equals log base 7 of 14. Since our log bases are the same, we can set the values equal to each other, and I'm going to multiply as I do that. So I'll get x squared plus x minus 6 equals 14. Then I will subtract my 14 from both sides, so x squared plus x minus 20 equals 0. I'm going to try to factor that. And I can think of 2 numbers that multiply to give me negative 20 and combine to give me 1. That's negative 4 and 5. So when I solve, my potential solutions are positive 4 and negative 5. Now I need to plug those in to check those, and I'm going to go all the way back to the original. So log base 7 of 4 minus 2 is 2. Log base 7 of 4 plus 3 is 7. Log base 7, 14, that checks. When I plug in negative 5, however, right away I get log base 7 of negative 7. And then log base 7 of negative 4. And I cannot have log values that are negative. So only x equals 4 will be a solution. Now let's do another sound intensity and loudness problem. So we have this same formula. And then the question is, what is the intensity in watts per meter squared of a sound wave that has a sound level reading of 125 decibels, which is the loudness of an average fire alarm? So we'll plug in 125 for L, and we will also plug in 10 to the negative 12 for I sub 0. Now the first thing we can do is divide by 10. So we have 12.5 equals log of I over 10 to the negative 12. We need to rewrite that logarithm as an exponential. It's an understood base 10. So in exponent form, that would be 10 raised to the 12.5 power equals I over 10 to the negative 12. Then multiply both sides by 10 to the negative 12, which will give you approximately 3.16 watts per meter squared. All right, that concludes our teacher talk over logarithms.